The global climate change affects us all. Our search for alternatives for emission-free energy generation has led us to the enormous potential of the oceans. The seas of the world hold tremendous energy that can be utilized, for example, in the tidal streams. Voith Hydro develops a turbine for the utilization of these tidal currents, with which this enormous energy can be converted into electric power. According to expert opinion, approximately 400 terawatt-hours per year can be won in this way from the seas of the world. The dimensions of a tidal current turbine are impressive. The turbine nacelle is almost 13 meters long, and the rotor has a diameter of 16 meters. In total, the plant is 26 meters high, which amounts to the size of a 7-story house. Once the installation vessel has reached the intended location for the underwater power station, the turbine is connected to a pre-placed subsea cable. For the future recovery of the turbine for maintenance purposes, guide chains are fixed to the foundation. The entire unit can now be immersed. After the underwater power station has reached the ocean floor, the turbine is started from the onshore control room. The sea current sets the rotor into motion, and the turbine begins to supply electricity with a generation pattern following the tides, regularly, predictably, and reliably. Each turbine has an installed power of 1 megawatt. The tides change their direction of flow approximately every 6 hours. The special rotor design of the turbine allows flow intake from both ends without having to adjust the turbine. The rotor simply changes its direction of rotation. This means that no complicated equipment is required for blade adjustment or nacelle rotation. During the development of the turbine, special attention was paid to simplicity, robustness, and eco-friendliness. The design has eliminated failure-prone transmissions and operates without oils and grease. Seawater is used for bearing lubrication. Another special feature lies in the avoidance of complex and sensitive seals. This has been achieved by designing the generator components to operate immersed in seawater. Via the sea cable, the generated electricity is directly transmitted to an onshore inverter station, then fed to the grid via a transformer. This robust and simple subsea technology gives long intervals between maintenance and hence minimizes the utilization of extremely expensive marine equipment. When the tidal current turbine is due for maintenance, the facility is shut down and disconnected from the grid onshore. For maintenance, the turbine is lifted from the water. To achieve this, a service vessel positions a cradle over the turbine. Buoys connected with the guide chains during installation float to the water's surface in response to an acoustic signal, and this allows access to the guide chains. Sliding on these chains, a lifting frame is lowered and directed below the turbine by maneuvering the vessel. The hydraulic clamp closes and then grips the turbine nacelle. Now the guide chains are tightened and the turbine can be safely lifted to the surface and disconnected from the sea cable. All maintenance work can be performed directly on the service vessel, protected by the harbor walls. The rotor blades are removed. The turbine is lifted to the service vessel and put on mobile assembly carts. Secure on these assembly carts, the nacelle can be easily disassembled allowing good access to all components that require maintenance. Even in small harbors with little infrastructure, the components can be exchanged easily and quickly with comparatively simple equipment, for example, a mobile crane. After completion of the repair or maintenance work, the turbine is returned to its location at sea and reinstalled. With its new tidal current turbines, Voith Hydro is making a vital contribution to the development of new and emission-free energy generation. The company regards itself as a pioneer in technology developments aimed at the utilization of all kinds of hydropower. Voith, engineered reliability.